Okay, we left off at number 28 on practice exam AB-3. And that one says the graph of f of x shown above consists of two line segments. What's the value 0 to 6 of f of x dx? So they gave us a line, and what we need to do, this just represents the area under the curve from 0 to 6. So we need to divide this up into three different areas that we can easily calculate. So from 0 to 3 we have a rectangle. So let's call that area 1. So the area is a height of 1, a base of 3, so that's 3. Area 2 is the triangle between 3 and 4. Okay, so that area is 1/2 times the base, which is 1, times the height, which is 1, and that's going to be a half. And then area 3 will be to the right between 4 and 6, and that's a triangle that goes below the x-axis. So we have 1/2 times a base of 2 times a height of -2. Okay, it's below the x-axis, so that's going to be -2. If we add those up, 3.5 minus 2, you'd get 1.5, which will be selection E. Okay, so that ends the non-calculator portion. Now you can get your TI 89 out and maybe work along with me on this. So number 29 says we have x plus sine y is equal to natural log of y. Then what is dy dx? So you could put this in your calculator, and I'm going to show you how to do that in a little bit. But I'm going to go ahead and write this out. We have the natural log of y is equal to x plus sine y. And we are going to take the derivative with respect to x. So that's implicit differentiation. So for the natural log of y, 1 over y dy dx is equal to the derivative of x is 1 plus the derivative of sine y would be cosine y, but don't forget we have to then multiply by the derivative of y, which is dy dx. I'm going to get rid of the fraction, I'm going to multiply both sides by y. That gets rid of the 1 over y. So if you do that, you would have dy dx is equal to y times 1 plus cosine y dy dx. So dy dx is equal to y plus y cosine y dy dx. Okay, let's get all the dy dx terms over to the left. So we have dy dx is equal to, or excuse me, dy dx minus y cosine y dy dx is equal to y. Then we can factor out a dy dx, and you have 1 minus y cosine y is equal to y. And then solving for dy dx, you have y over 1 minus y cosine y, and that is selection E again. Alright, so we did this by hand, and you could probably do that by hand a lot faster than what I just explained. You could probably do it in the, you get 3 minutes a problem on these calculator multiple choice. So you could have done that in 3 minutes or less pretty easily by hand, but if you want to try it in your calculator, let me show you how you put that in for implicit differentiation. So you'd hit F3, and then one of the options, if you scroll down, is imp diff. Alright, and then you'll have a left parenthesis and put natural log of y, you have to put the y in parentheses, is equal to x plus sine y, comma x, comma y. You have to put both variables. Okay, so the answer it will give you is minus y over y cosine y minus 1. Okay, so that's not exactly any of the possibilities you have on your sheet, but if you will just multiply that by -1 over -1, you'll see that that's just y over 1 minus y cosine y. Okay, so can go through that your calculator and do it pretty quickly, but it doesn't give you one of the options on your sheet, so you have to realize that this is the same as option E. But if you can realize that, then it's definitely a fast way to do it. All right, number 30 says if y is equal to sine of x minus sine x, what is the smallest positive value of x for which the tangent line is parallel to the x-axis? Okay, tangent line parallel to the x-axis means where's the point where the slope is equal to 0? Okay, because that would be parallel to the x-axis. So what you need to do is just graph the function and then trace it. And when you trace it, you'll use that target, right, that looks like that. And the x value that where the slope is equal to 0 is about 2.310. So that is selection B. So go ahead and try that one in your calculator and see if you can get that to work out. If not, just let me know. Put a question mark there when school reconvenes. I can show you how to do that. All right, number 31. 31 is kind of like we had a worksheet, and what you have to realize is that 31 is inverses. Okay, so f and g are functions defined for all x, so that f of g of x is equal to g of f of x is equal to x. That means that f of x and g of x are inverses. Okay, so what that means is that g prime of b is equal to 1 over f prime of g of b. Okay, that was a formula that we had to learn when we did that worksheet. So you know that f of a is equal to b and g of b is equal to a. So with the inverse, the input of one is equal to the output of another if they're inverses. So g prime of b is going to be equal to 1 over f prime of a. And it says that f prime of a in the problem is equal to c, so that's going to be 1 over c, and that selection is C. Okay, so that one might be a little bit of a tough one to get. Certainly not a calculator type problem. You just got to kind of remember the reciprocal relationship of inverses to each other, 1 over c. All right, number 32. Okay, so that one says the depth of water in a tidal basin can be represented by the formula of h of t is minus cosine pi t over 12 plus 4, where t is time in hours starting at midnight. That's the key, starting at midnight, measured in feet. What's the average depth of the water between noon and 3 p.m.? Okay, so we've got to realize on that, if you want to know average, you've got to remember the average value formula. So what that tells us, first of all, if midnight is 0, then noon has to be 12. And 3 p.m., then if noon is 12, then 3 p.m. is 15 hours. So to get the average value, it's 1 over b minus a, and then we integrate from a to b of h of t dt. So that's going to be 1 over 15 minus 12, integrate from 12 to 15, of minus cosine pi t over 12 plus 4 dt. So you can try that in your calculator. But the answer that you should get is 4.9, about 4.900, which is selection E. Alright, so that is number 32. Number 33. So we have a function f of x is differentiable between -7 and -4, has only one critical number, -5. So what feature must the graph have at where x is -5? Okay, what feature if f prime of -7 is -1 and f prime of -4 is 1/2? Okay, so let's just draw a sign line here. What it's asking, if you look at the answers, it's saying, does it have a max, does it have a min, or whatever. So our critical point we know is -5. We know at -7, the value of the derivative is negative, so we can put negatives there. And at -4, the value of the derivative is positive. So we're coming down like that, coming up like that. So we know we have a min. And so we can pick selection A. Alright, so definitely not a calculator type problem. You can zip through that pretty quick if you can remember to draw the sign line. Alright, number 34. Okay, number 34, we just got to go through those. So for part A, says the limit as x approaches 2 of f of x is equal to 7, then f of 2 is equal to 7. Okay, is that true, or is that not necessarily true? Well, we know from limits, if you have a hole, okay, your fingers come together, so add x equals 2, okay, and y equals 7, that doesn't mean f of 2, it's undefined at 2. So f of 2 doesn't have to equal 7. There could be a hole. So part A is false. Part B, we have the limit as x approaches 5 of f of x is equal to -3. Then is -3 in the range of f? Well, that's the same kind of thing. What if we have at x equals 5 and y is -3? What if we have a hole there? If that's the case, then we're undefined at x equals 5, so it's not in the range, so that one also is false. Part C, it says if the limit as x approaches 1 from the left is equal to 1 from the right, then f of 1 exists. Well, what if we have a hole at x equals 1? The limit, if you bring your fingers together, the limit from both sides is going to be equal to the other side, but that doesn't mean that f of 1 exists if there's a hole, so that one is false. Alright, and then D says if the limit as x approaches 3 from the left does not equal x approaches 3 from the right, then it doesn't exist. Well, that one I can get behind. So let's say we have something like this. And this is 3. Approaching from the left does not equal approaching from the right. That's the classic example of does not exist. So D is true. So you need to pick D on number 34. Okay, this one you really just got to remember to use the absolute value when you want to know total distance. So s of t, we're going to integrate v of t dt. Alright, so to get a total distance, because this thing can be moving back and forth like that, so if you want the total distance, s of t is going to be, you have to do the absolute value. Okay, so s of t is going to be the absolute value from 0 to 3 of 5 minus e to the t dt. And you've got to use your catalog on your calculator and pick ABS when you plug that in. Okay, and the answer when you do that is 12.18, which is selection D. So go ahead and give that a try on your calculator. Number 36 I think I can fit on the board here. All right, 36 says we've got a graph that looks like this, okay? And it says at which point on the graph above are both the first and second derivatives negative? Well, the first derivative is negative at, or excuse me, not at, but where the slope is negative. And then the second derivative